Okay, so we forgot about our video, and most of it's already on the board, but we're graphing systems of inequalities, and the picture is the solution. So step one, they're going to give us two. I wrote mine in two different colors to make it easier. You could do yours in two different colors too. I keep colored pencils over there if you want to do yours. It does help make it feel neater. So you're always welcome to use mine, or you can do it with a pen, like if you have different colored pens, but that's risky. Doing it with a pen, you know what I mean? So, okay, step one is rewrite each one in slope-intercept form. So I just got the y by itself, and now I'm going to graph it. I put a dot on the 5 on the y-axis, and then what's the slope of this inequality? Negative 2 over 1. So I want to go down 2 over 1, down 2 over 1. I do it a couple of times to make it easy to draw my line. Now, I have to ask myself what kind of line I want to draw. Because normally, this means open circle, and with the line under it means the filled in circle, right? We have to do that on here also. So if we're trying to draw it on this 2D graph, what happens is the open one, the one that would normally be open, is a dotted line. And then we use a solid line if there's an or equal to. So it's the same idea, filled in and not filled in. So here, in this problem, am I going to use a dotted line or a solid line? This is the number one place I mess up. Like, I forget to do it, and then I have to go back and erase in between. But I'm going to do a dotted line because it did not have an or equal to. So here's my dotted line. Dun, dun, dun. All right, what else do we do when we're doing it on a line? We have to decide if it's open or closed, and then we decide what? When we're doing inequalities. If we were doing it on a number line and we had x is less than 5, that means open circle, but the next question is, which way do we shade, right? So over here, less than 5 just means shade the numbers that are less than 5. This is a little more complicated because less than is a little more complicated on this kind of picture. Less than could mean below, because that's where the numbers on the y-axis are less than. Less than could mean to the left. So it's a little bit not quite as clear where to shade. Now in this case, it seems to me that I would call this below, and it's also the to the left, so it's probably going to be here. But I'm going to tell you that for me, the easiest way to check where to shade is to pick a point and plug it in. So I picked 0, 0 because it's so easy to plug 0, 0 in. I'm going to plug it in. If I plug it in and get a true statement, that means I need to shade where the 0, 0 is. If I plug it in and get a false statement, it means 0, 0 should not be shaded, and I should shade the other side. So I'm going to plug it in here. 0 greater than negative 2 times 0 plus 5. True or false? Is 0 greater than 5? Oh, see, I would have been so wrong. Oh, we're doing greater than. This does feel like the greater than part, doesn't it? It just has a greater than feel because it's above. Yeah, but like I said, that's a little harder. Sometimes when they're more flat, it's really hard to try to guess. So I plugged it in, and this is a false statement, right? I plugged in 0, 0, this point, and I got a false statement. That means 0, 0 should not be shaded. So I shade all of this, which is very hard to do with an expo marker. This is where I highly recommend colored pencils to you, because we're going to have to do it twice. Remember, we're trying to find the solution to the system, and the system is where they overlap, because we want what's a solution to both. So every number over here is a solution to this inequality. All of these numbers, not just, in fact, the ones on the line won't be true. They'll give us equal to, and that's not what we want. So every number over here is a solution to this one. But we want to know what's a solution to both. So now we have to do the other one, and I'm going to switch colors. So I'm going to take this. I'm going to do the same thing. I started writing out steps, and then I just quit. Sorry. So first thing I'm going to do is I'm going to get it in slope-intercept form. This one is trickier, though, because when I minus that 3x on both sides, I'm left with a negative y. That's not slope-intercept form. Negative y isn't slope-intercept form. What do I need to do? I need to multiply the whole thing by negative 1 or divide the whole thing by negative 1. Not that that's hard, but you have to, in your head, that means this flips. Anytime you multiply by a negative, that sign flips. And that becomes positive 3x and negative 2. So every sign changes, including this one.
Does it really matter which way the sign faces when you're graphing?
Yes, because it's going to be whether we shade, which side we shade.
Oh yeah, right, that makes right, because numbers, right.
Okay, so I get it in slope-intercept form. Then we graph it, and we have to remember whether to do it dotted or solid. It's not the end of the world. I mess that up constantly. If you accidentally do a solid line when you meant dotted, you just go back and erase some of it. But this one's going to be what kind of line? Dotted or solid? Dotted, because we don't have the or equal to. So I'm going to start where on the y-axis? Negative 2. Start at negative 2. And what's the slope for this line? 3 over 1. So from here, I go up 3 over 1. Up 1, 2, 3 over 1. Do it a couple of times just to make it easier to draw. And then I'm going to do my little dotted line. It starts looking real sloppy real quick when I'm doing it with Expo. I'm sorry. It's so much prettier with colored pencil. The shading in the book is so pretty too. They use red and blue, and then when it overlaps, it makes purple. It's really pretty. If you do yellow and green, or like yellow and blue and make a green over it, it's pretty. But it's not pretty here. Sorry. Now I have to decide where to shade the blue. So I'm looking at the blue line. I'm trying to pretend the green one doesn't exist. I want to know whether to shade here or here, which side of the blue line. This says y is less than. This one to me is a little trickier because this is less than on the x-axis, but less than here feels like it would be that way. That's why I plug in 0, 0. If I can't do 0, 0, if 0, 0 is on the line, then I pick something equally easy, like 1, 1 or 1, 0. I try to pick something that's easy to plug in. But it really doesn't matter. You just pick a point. I'm picking 0, 0. I'm going to plug it in. If I get a true statement, it means this side should be shaded. If I get a false statement, it means this side should not be shaded, so I'm going to shade over there. So 0, less than 3 times 0. Minus 2 is 0, less than negative 2. Is 0 less than negative 2? 0 is not less than negative 2, so this point, 0, 0 should not be shaded. I should shade over here. And here's where it gets tricky. The answer to the question we were asked is the overlapping part, the part that we shaded twice. So that would be this chunk. You see it? Oh, Expo, you suck. I'm so jealous of Gibbons' chalkboard. Like right here, I could do the prettiest colors. I could just, you turn your chalks up. Whatever, we work with what we have. So this chunk is the answer. The picture is the answer. Like you're not going to be able to go over here and be like, oh, the answer is this section. Because that's what got shaded both times. So we graph with dotted or solid. We plug in a point to see where to shade. Then do it again. Because you got to do it twice. We can here, I'll put the little repeat symbol right there. This is a musical.
What do you mean by do it again?
Because you're going to have to. Like when we're doing systems of inequalities, we'll have to. So you're going to do this one, put it on your graph, then do the second one. You kind of have to start all over again. So you will have to. So we'll have to do it twice. Yes?
This always gets me confused. The x part of an equation, like not the b but the x. Yeah. If it's negative, is that a negative slope? Like it's going down?
So yeah, you read a graph left to right, just like you read a sentence. So we read it like this. If our slope is negative, it should be going down as we trace it from left to right. So if you start on the left part of the graph and you trace it down, it should be going down if we got a negative. If we get a positive, this one we got a positive. So as we go left to right on this blue one, I start at the first point on the left is going up as I read left to right. So it doesn't, and where the negative is doesn't matter. This is the same as this. Like they're both the same thing. They both mean that it should be going down. And even if it's on the fraction bar, like sometimes the book, especially when it's typing, like they'll get it right on the fraction bar, all the same thing. They all mean that as we read it left to right, it should be going down. So when we put our point on the y-axis, we want to go down and over. I mean, you can go the other way to get some more points. You know what I mean? Like 3, 1, so I can kind of go reverse of that if I need some more points on my graph. All right. I didn't give you very many of these because they take a while to do correctly, and I would rather you do them correctly than do them fast.
So for the first one, when you're solving y is greater than x, I know you just put in like y is greater than 1x plus b, but what do you put as b? 0,
because you didn't add anything. I'm going to do that one. For people who are still stuck, I'm going to do the first one. Your assignment in 4-7 is just 4 of them. 17, 21, 25, 29. 17, 21, 20. I picked the best ones.
And if it doesn't have an equal sign, it's dashed?
Yes. So, if anybody wants graph paper, but I'm going to do 17 as well. If you feel like you've got this, go ahead of me. If you feel like you need one more example, watch and do it with me. So there's graph paper there. You're not going to be able to access graph paper. But 17 says y is greater than x. There's one of them. And the other one says y is less than negative x plus 1. So we're going to graph them both on the same graph, see where they overlap. Again, if you've already got it, stop the video or go on ahead of me. Because this is number 17. I will need to clear this off.
So I guess it needs to work on it.
Yes. You've already done all of them? Dang. Okay. For this one, it's already in slope-intercept form because the y is isolated. But we could get real fancy and call it 1 over 1x plus 0. You don't have to write that out, but this is what's happening. Nothing is added. So there's our intercept. And the slope is a 1 over 1. So I start at 0, and I go up 1 over 1 many times as I feel like it. We didn't get any solid lines in our examples. There's no or equal to right here. So it's going to be a dashed line. I should do it right. Just get my ruler. And I'm going to dash my line. I thought the sound effects helped. Okay. I dash my line, then I decide where am I going to shade. Now I can't plug in 0, 0 this time because 0, 0 is on the line. And here's what would happen if you did. You get equal to, so you can't answer the question. Like, it doesn't really work there. So we have to pick a different point, and we're going to pick one on purpose that's easy to plug in. 1, 1 is also out because it's on the line, but how about the point 1, 0? That's easy to plug in. So I'm going to figure out if that works or not. So my point that I'm trying is 1, 0. So 0 goes in the y spot, 1 goes in the x spot. I don't know why I did that. I should have just done it like that. But is 0 greater than 1? Nope, it is not. So the point that I chose should not be shaded. Instead, it should be shaded. Golly, that's not even a little bit writing. We're going to have to do one on camera. How boring! Hopefully somebody's watching it at 1.5 speed. That's how I watch it every morning. I watch no videos at regular speed, ever. Okay, here we go. Shade this side. How ugly! But accurate, mathematically. Okay, let's do it again. This one's already in slope-intercept form, so we don't have to do any work there. And I can kind of write that if it makes us feel better. So I start at 1, a y-axis because the number by itself is my y-intercept. And then I go up 1 over 1 as many times as I feel like it. They have the same slope. They're parallel. It's a dotted line again. This is a weird one. How pretty. Okay.
This is 17.
That's not about 17.
Did I write the wrong problem?
I think so.
Oh, I should have gone down 1 over 1. It's a negative 1 over 1x. There's a fun sound too. Okay, so there, but then down 1 over 1. Does that look better?
Yes, ma'am.
And we'll dot it. Sound effects help. Okay, but now I have to figure out where to shade. Thankfully, this one doesn't go right through the 0, 0, so I can use my easy one and I can plug in 0, 0. 0 is less than 0 plus 1. Less than 1. That is true. So I do need to shade the 0, 0. So that'd be this side. Which means the overlap is right there. Oh, that's so hard to see. Right there in this chunk. That's the part that was shaded both times, right in this little triangle. So this is the answer, and there's no other way to write it than the picture. So, quick summary. Put it in slope-intercept form. Graph it using your intercept. That's the number by itself. If there's nothing there, then treat it like it was a 0. And the slope, which is the number right in front of the x. If there's no number right in front of the x, then we use 1 over 1. So this tells us where to start, and this tells us where to go. If there's a line under here, like so, then that means we do a solid line. If there's not, we do a dotted line. And then to figure out where to shade, I find that the easiest way to figure out where to shade is to plug in some point and see if it works or not. And then put your little overlap. There's the answer to the question. Yes.
For